We focus on technologies and advancing technologies. We believe that they can be used for, if you call it, Earth-centric applications, as well as going beyond Earth to exploit space resources, for example. We tend to focus on these technologies, and in the short term, of course, most business is centered around Earth. We believe this is important to test the technologies, to show that they can deliver what's promised before going beyond Earth. So we tend to partner up with companies that often have services and applications that are Earth-centric. This can be geolocation, navigation, communications, messaging, Earth observation, for example. But we think developing these technologies is essential to go beyond Earth to do space mining, for example. That's of course a very long-term vision that's extremely challenging, but we believe that all these technologies we're developing are absolutely critical for this purpose. Right now I'm standing in what we call our LunaLab, which is one of the facilities we've invested in to be able to test autonomous systems and robots on an environment that's similar to the surface of the moon. This we use both for research purposes but also for educational purposes. So we have students following our master program who can run projects and test their solutions in a realistic environment. We have similarly invested in a communication and networking laboratory where we can do rapid prototyping of solutions and testing them in an experimental environment. Students can work on implementing solutions. We have a CubeSat lab where we can look at assembly of different parts and testing of them in a realistic CubeSat. Our long-term intention is to have a mission-based program where we every 2 years have a program of planning and design and eventually assembly testing and also launch of a CubeSat to later collect data. For this purpose we also have a concurrent design facility which is state-of-the-art and allows students to train on how to design missions, bringing in different types of expertise and also working with different software solutions for this purpose. Another exciting lab that we're developing is a 2D zero-gravity lab. So this is be a facility which has a very planar floor surface on which we can have platforms with forced air. So they float on cushions of air and thereby eliminating friction in at least 2 dimensions and also a rotational dimension. And this will allow us to emulate rendezvous in space and test sensor systems, navigation systems, control systems. And these are some of the projects that we're running right now and have actually several research teams contributing to this. And hopefully in a year or two you'll be able to visit our labs and see demonstrations of this technology. Well, good science, it's about creating new knowledge, new insights, finding new solutions, new designs to challenging topics. So this requires, of course, that scientists are well aware of what's happening in their field. On a global scale. So research is international by its nature, and to really produce good science you need to be very well connected with the community and know what's going on around the world to be able to make advances in a certain area. But I'd like to say that's not sufficient. There's always this question about is the work, is the science, the research relevant? Is it something that is of interest to practice, to a large community? So we always weigh the question of making scientific advances, but at the same time doing it in areas that are relevant. Something that we work a lot with in SnT, the research center I head, is to find the sweet spot where we can make advances and also bring these advances into practice. Bringing them into practice is challenging, and we always believe the best way of doing this is through collaboration with practitioners. So we work a lot with building partnerships with industrial partners and sometimes with government partners, where we can take our outcomes from research and then validate them in real environments. So not only producing scientific papers which are read by other scientists, but also test those ideas under as realistic conditions as possible. And this is always a very good learning experience, because it never works the first time. You have to go back and refine your ideas and test them again. And this is something that requires a lot of time and effort and a special type of expertise as well. But I think that goes hand in hand with what we call good science. It all starts with people, with attracting talent. So in the areas we're active, there's a fierce competition globally for talent. If we want to be competitive in this area, we have to recruit on a global scale, not just from Luxembourg, not just from Europe, but beyond. In our research center, we have a very international environment with over 62 nationalities coming from all over the world. Then it's about providing the right conditions for researchers to excel, to be able to pursue their ideas. I think Luxembourg offers fantastic conditions in this respect, where the government has been investing in research and higher education for a number of years and increased that in investment. And then it's about bringing the people together also. I run an interdisciplinary research center, and we try to bring in different types of expertise. Computer scientists, engineers, people that have experience in human behavior, in regulatory and legal aspects. And this is often where a lot of exciting things happen, are at the interfaces between different disciplines. Also, the way we work is we try to tackle real-world problems. As soon as you do that, you naturally have to bring in expertise from different areas. And this creates a lot of interesting ideas and innovative solutions, in my experience. Ever since I launched SnT in 2009, it's been very important to work together with the private sector in developing research activity. Luxembourg is a small country, and we're a small center, so we have to be focused on certain areas. We cannot cover everything. So our partnerships are a way of seeing what areas, what research areas we can develop successfully in Luxembourg. So we have what we call our partnership program, where we enter into long-term strategic relationships with private companies, but in some cases also with public entities. We define projects that have a scientific interest, of course, but that are of high relevance to the partner. These are typically 3 or 4 year agreements, so we can tackle very challenging problems. We have PhD candidates, we have senior researchers working together on the projects, and we call it collaborative research, because it's very important that we work together with practitioners that have the domain expertise. In this case, space companies that have the expertise around the domain of space. Working with large companies and small startups, it's very different. From our perspective, it's often easier to work with a large company that has a research department. They have a time horizon that can be several years, and that fits well also with the research perspective we have in our projects. At the same time, we see a tremendous dynamics and innovations in startup companies. And we also feel it's our role to support startups as well through research activities. So even though the time perspective is often different, startups often are under very tight constraints and have to deliver in a short period of time. We are finding ways of working together. One example is the facility we're standing in, which is a resource for some of these startup companies. So we can work together with them, exploiting the infrastructure that we have, and also to develop their business. Well, there are a lot of exciting things happening in Luxembourg regarding space right now. There's of course a history with companies like SES who have exploited space applications for decades. But with the more recent initiatives creating a legal framework around space and creating investment funds, a lot of small innovative companies have come to the country and are trying to develop their very innovative business ideas. Going to space requires a lot of different technologies and expertise, and of course Luxembourg, being a small country, is not able to pursue all of those areas. At SnT, we're trying to contribute with our expertise to advance this sector, and we focus, simply put, you could say, anything that has to do with data, with algorithms, with modeling and software. Those are topics where we have very good expertise. So these are the areas we're trying to pursue also in space. In space, we have to develop systems that are autonomous, and this is one of our focus areas, looking at autonomous systems on robotics, on control. You need to be able to navigate, so we're looking at navigation, geolocation. You need to be able to communicate, so we're looking at communication networks in space and beyond. We're looking at mission-critical software. So designing software solutions that go on spacecraft that will not have the option of human intervention, that places other demands on the development of the software. We call it mission-critical software systems. We're also developing areas like remote sensing. You have to be able to do very accurate and high-precision remote sensing if you want to be able to develop services in space. There are other areas of expertise in Luxembourg also, perhaps not with our institution, around material science and other areas as well. I'm very excited about Luxembourg's participation. As I mentioned before, Luxembourg is a small country, and we cannot tackle a big mission by ourselves. That's not realistic. We have to team up, and I think space has always been an area of collaboration internationally. So I think it's exciting that we take an active part, and I hope that in a few years actually we will have technology developed in our laboratories that will be deployed in space and will contribute to this mission.